Hi guys, and welcome to this tutorial where we'll be looking at direct proportion. Now let's first of all look at the definition of direct proportion. Now we say that two different quantities are directly proportional if, as one quantity increases, the other quantity also increases at a constant rate, or as one quantity decreases, another quantity also decreases at a constant rate. Now we'll look more into this definition shortly, but if two quantities are directly proportional, there are many ways to illustrate how one quantity varies in proportion to another quantity. In this tutorial, we're going to learn about how to describe direct proportion, specifically using formulas. So let's start with an example, and let's take for example the cost of apples. If one apple costs £1, two apples cost £2, and three apples cost £3, then what formula can you use to describe the relationship between the number of apples and the cost of apples in pounds? Well, if we let A be equal to the number of apples and C be equal to the cost of apples in pounds, well then we can use the formula C is equal to A to describe the relationship. And that's because in this scenario, the number of apples is exactly equal to the cost of apples in pounds. And these two variables will be seen as directly proportional because when A, the number of apples, increases, C, the cost in pounds, also increases by exactly the same amount. And when the number of apples decreases, the cost of apples in pounds also decreases by exactly the same amount. When we use formulas to describe relationships where variables are directly proportional to each other, the relationship works both ways. So you could have also written that A is equal to C. Let's have a look at another example. If 3 pineapples cost £6, 6 pineapples cost £12, and 9 pineapples cost £18, can you see the relationship between the number of pineapples and the cost in pounds? Notice that the cost in pounds in this scenario is twice the number of pineapples. So say we let P be equal to the number of pineapples and C be equal to the cost in pounds, then the formula that we could use to describe the relationship between these variables is that C is equal to 2 times by P. In this example, the cost in pounds is also directly proportional to the number of pineapples. However, the rate at which the cost increases or decreases relative to the number of pineapples is different than the previous example. For this example, when the number of pineapples increases by a certain amount, the cost of pineapples increases by twice the amount. Or when the number of pineapples decreases by a certain amount, the cost will decrease by twice the amount. So what this shows us is that two variables can be directly proportional to each other, but the rate at which one variable increases or decreases relative to the other variable is not always exactly the same, as we saw in this example. These two variables will be directly proportional as long as this rate remains constant, and this was the rate that we were referring to in the definition above. In general, if we say that the variable y is directly proportional to x, we use this symbol, which looks like a fish sign, to show this relationship, okay? So another way you could say that y is directly proportional to x is y fish sign x. The equivalent equation to this statement is that y is equal to kx, where this value k is what we call the constant of proportionality. And this constant k is the rate at which one variable increases or decreases relative to the other variable. In the previous example, the constant of proportionality k was equal to 1 because the cost increased or decreased at exactly the same rate as the number of apples, increased or decreased. Comparing with this equation, it would normally be the constant value that's multiplied by the variable. Since a is the same as 1 times a, the constant k is equal to 1. For the pineapples, the constant k was equal to 2 because the cost increased or decreased at twice the rate as the number of pineapples. So in these examples, we were able to create a formula which showed the relationship between different quantities that are directly proportional to each other, because we could see a pattern in the relationship between the quantities. But if you had already been told that the variables p and c were directly proportional, then using equations in the way we've just seen, then all you actually need is just one instance of this relationship in order to work out the correct formula relating the two variables. And this is how you would see a typical question. So let's go ahead and have a look at a typical question on direct proportion. So for the first example, we're told that y is directly proportional to x. When x is equal to 500, y is equal to 10. Find the formula for y in terms of x. So since we are told that y is directly proportional to x, we can use this symbol to show this relationship. And therefore, we can say that y is equal to kx, where k is the constant of proportionality that we need to find in order to complete this general formula. So let's label this equation 1. Now, using the information we are given, when x is equal to 500, y is equal to 10, which is just an instance or a snapshot of the relationship between y and x. Now, using the fact that y is directly proportional to x, by subbing these variables into equation 1, we can use this one snapshot to find the value of k, which will subsequently give us the general formula for y in terms of x, which is very powerful considering the fact that there are several different values that x and y could take. So subbing these values into equation 1, we get that 10 is equal to 500k, and dividing both sides of the equation by 500, we get that k is equal to 1 over 50, or 0.02, which you could write as a decimal. So now that we've found k, if we substitute this value of k back into equation 1, we can find that the general formula for y in terms of x is y is equal to x over 50. And at this point, I would generally write a square around this formula just to remind me that I can use this formula to find any value of y for any given value of x, and vice versa. And just to note, this relationship between y and x would be seen as a linear one because the variables we were given in the question were linear variables. Okay? Now, I briefly went over this earlier, but it's a useful fact to know that if y is directly proportional to x, well, that means that x is directly proportional to y. The relationship works the other way around. Let's have a look at this in practice. So using the same method to look at this relationship the other way around, we could first start by writing this statement, x fish sign y, and therefore x is equal to ky, where k is our constant of proportionality to be found. Let's label this equation 2. Now, in order to find k, we need to sub these values of x and y into equation 2, and therefore we get that 500 is equal to 10k. And dividing both sides of this equation by 10, we get that k is equal to 50. Now, in order to find our general formula for x in terms of y this time, we need to sub this newfound value of k back into equation 2 to get the general formula to be x is equal to 50y. Okay? And comparing both equations, you should be able to see that these two equations are equivalent. And you'll see this by dividing both sides of this equation by 50 to give you this equation, y is equal to x over 50. So this was just to show you that we could have also looked at this relationship the other way and still got an equivalent result. But since we were asked to find the formula for y in terms of x, you should make sure that you use this method in order to make y the subject of this formula. Okay, let's have a look at the next example. So here we're given that y is directly proportional to x. When x is equal to 2, y is equal to 36. The first part asks us to find the formula for y in terms of x. So using exactly the same method as before, since we're told that y is directly proportional to x, we can describe this by writing y fish x, and therefore we can write that y is equal to k times by x, where k is a constant to be found, and we can label this equation 1. Now we can find the constant k by using the fact that when x is equal to 2, y is equal to 36. So subbing these values into equation 1, we get that 36 is equal to 2 times by k. And to solve for k, we need to divide both sides of this equation by 2, giving us that k is equal to 18. Now subbing this value of k that we've just found into equation 1, we get that y is equal to 18x, giving us a general formula for y in terms of x. Okay? Now the second part of this problem goes a step further and asks us to find the value of y when x is equal to 5. So given that we've now found a general formula for y in terms of x, we can now use this formula to find the value of y when x is equal to 5 by simply just subbing x is equal to 5 into this formula, giving us that y is equal to 18 times 5, and therefore the value of y when x is equal to 5 is equal to 90. Okay, let's look at the next example. In the table below, D is directly proportional to C. The first part asks us to find the formula for D in terms of C, and the next part says hence or otherwise complete the table. So I'm going to leave you with a few moments to pause the video to have a go at this one yourself, and when you come back, I will walk through the solution. Welcome back, guys. Now, solving the first part, which asks us to find a formula for D in terms of C, since we're told that D is directly proportional to C, we can write the statement using the fish symbol, and therefore we can say that D is equal to K times C, where K is a constant to be found. And let's label this equation 1. Now, in order to find K in this instance, we need to use the table to find a case where we know what the value of D is when we know the value of C. And if you look at the table, we can find this case right here. When C is equal to 3, we have that D is equal to 12. So subbing these values into equation 1 gives us that 12 is equal to 3 times K. And dividing both sides of this equation by 3 gives us that K is equal to 4. So subbing this newfound value of K back into equation 1, we get the general formula that D is equal to 4C. The next part says hence or otherwise complete the table. So using the word hence, it's possible that we can answer this question using the previous part. So using the formula that we've just found for D in terms of C to work out the value of D when C is equal to 5, all we have to do is sub this value of C into this formula, and therefore D is equal to 4 times 5, which is equal to 20. To work out the value of C when D is equal to 28, we need to sub D equal to 28 into this formula. And so in order to work out the value of C, if D was equal to 28, we would need to do 28 divided by 4 to get that C is equal to 7. And finally, to work out the value of D when C is equal to 12, we need to simply sub C equal to 12 into this formula. Therefore, D is equal to 4 times 12, which is equal to 48. Okay, let's have a look at the next question. So here we're told that D is directly proportional to S squared. When D is equal to 900, S is equal to 20. Calculate the value of D when s is equal to 25. So in previous examples, once we found a formula for two variables that were directly proportional, we saw that the relationship between the variables was linear. But when two variables are directly proportional, the relationship doesn't always have to be linear. And here we have our first example. This is also the first example where we haven't been asked to find the formula that shows the relationship between the variables given in the question. However, in order to calculate the value of d when s is equal to 25, we have to find this formula first. Since we're given that d is directly proportional to s squared, we can also write this as follows. And therefore, using the same method, we can say that d is equal to k times by s squared, where k is our constant of proportionality that we need to find. And we can label this equation 1. So using the information that we've been given in the question, when d is equal to 900, s is equal to 20, so subbing these values into equation 1, we get that therefore 900 is equal to k times by 20 squared. Evaluating the right hand side, we get that 900 is equal to 400k, and dividing both sides by 400, we get that k is equal to 9/4, which you could also leave as a decimal as 2.25. So now we found k, we need to simply sub this back into our equation 1 to work out that our general formula for d in terms of s is d is equal to 9/4 s squared. Okay, and notice that this is actually a quadratic formula showing the non-linear relationship between two variables d and s that are directly proportional. Okay, so now we've found our formula. We need to use this formula to calculate the value of d when s is equal to 25. And we can do this by simply subbing s is equal to 25 into this general formula, giving us that d is equal to 9/4 times 25 squared. And if you work this out in your calculator, you would get that d is equal to 1406.25. Let's have a look at the next example. So here we're told that y is directly proportional to x. Which graph represents this relationship? So we're going to do this by process of elimination so that you can get a better understanding of what's going on visually. So starting with A, looking at this graph, we can see as the value of x increases, the value of y decreases. Given the definition of direct proportionality, which states that two quantities would both increase or both decrease at a constant rate, we could immediately exclude this example. Now looking at graph C, we can see that this is a parabolic curve which goes through the origin, which represents a non-linear relationship between the variables x and y. Now since we're told that y is directly proportional to x, we need to assume that the relationship between these variables are linear. And since this is non-linear, we can also exclude this option. In fact, this graph C would actually represent two directly proportional variables that have a quadratic relationship, just like the previous example, which leaves us with two contenders, graph B and graph D. Now we can see that both graphs are linear, and as the value of x increases, the value of y increases in both cases, which leaves us with a bit of a dilemma. But using the definition of proportionality and the formula that we derive from it, we can work out which graph represents this relationship. Now, given that y is directly proportional to x, we can write this as follows: y fish symbol x, and therefore y is equal to k times by x, where k is our constant of proportionality. So this is the equation that holds for any pair of linear variables that are directly proportional. Now, since we said that both graphs are linear, it means that both graphs have an equation that takes the form y is equal to mx plus c, as you should be well aware of the general equation for a straight line. Now let's compare this equation with the general equation for linear variables that are directly proportional. On the left hand side, we both have y, On the right hand side of the first equation we have kx, and on the right hand side of the second equation we have mx, and these values k and m both represent the same thing, the rate at which y changes relative to x, which for this equation you would commonly refer to as the gradient. So the only difference between these two equations is that in the first equation there is no value of c. In other words, c must be equal to 0. And this is true for the equation of any variables that are directly proportional, whether they're linear or non-linear. And since the c part of this equation is equal to 0, it means that the line of this graph must go through the origin. And since this graph doesn't go through the origin, we can also exclude b, which leaves us with this graph d, which shows that y is directly proportional to x. Okay? Let's look at the next problem. Here we're given that c is directly proportional to the square root of y. When c is equal to 12.8, y is equal to 16. The first part says express c in terms of y, and the next part says find c when y is equal to 400. So why don't you have a go at this question, pause the video, and when you come back, I'll show you the solution. Welcome back. So in this question we're told that c is directly proportional to the square root of y, and therefore we can write this statement, c fish symbol the square root of y, and therefore we can write the equation c is equal to k times by the square root of y, where k is a constant to be found. So let's label this equation 1. Now, given the fact that when c is equal to 12.8, y is equal to 16, we can sub these values into equation 1 to get that therefore 12.8 is equal to k times by the square root of 16. Dividing both sides by the square root of 16, or dividing both sides by 4, we get that k is equal to 3.2. So subbing this value of k back into equation 1, we get a general formula expressing c in terms of y, as c is equal to 3.2 times by the square root of y. For the second part, we need to find c when y is equal to 400. So simply subbing the value of y is equal to 400 into this formula gives us that c is equal to 3.2 times by the square root of 400. And if you work this out on your calculator, you'll get that c is equal to 64. Okay, let's have a look at the next problem. Y squared is directly proportional to the cube root of f. When y is equal to 4, f is equal to 125. Find the value of y when f is equal to 27. Okay, so once again, pause the video to have a go at this problem. When you come back, we are going to walk through the solution. Welcome back, guys. Okay, so this is another example where we're not initially asked to find a formula which expresses y in terms of f, but in order to find the value of y when f is equal to 27, we need to find a formula, a general formula, which links the two variables. So given that y squared is directly proportional to the cube root of f, we can write this statement, y squared, fish symbol, cube root of f, and therefore y squared is equal to k times by the cube root of f, where k is a constant to be found. Let's label this equation 1. Now subbing these values into equation 1, we get that 4 squared is equal to k times by the cube root of 125. Evaluating these values, 4 squared is equal to 16, and the cube root of 125 is equal to 5, and therefore 16 is equal to 5k. And dividing both sides of the equation by 5, we get that k is equal to 3.2. Now in order to find the general formula linking the variables, we need to sub this value of k back into equation 1 to get The general formula is y squared is equal to 3.2 times the cube root of f. So in order to find the value of y when f is equal to 27, we need to sub this value of f into this formula, giving us that y squared is equal to 3.2 times the cube root of 27. The cube root of 27 is 3, and therefore y squared is equal to 3.2 times by 3. Working out the right hand side, we get that y squared is equal to 9.8. And in order to find the value of y, we need to take the square root of both sides, giving us that y is equal to positive 3.10 rounded to 2 decimal places. Now we have to be careful here, because when we take the square root of a value, you're normally advised to use the positive and negative version of that value. Now, assuming we took both the positive and negative version of this answer, what we're saying is that for a positive value of y equal to 3.10 rounded to 2 decimal places, we get f equal to 27. And we're also saying for a negative value of y equal to negative 3.10 rounded to 2 decimal places, we also get the same value of 27. Now, whilst this is mathematically true, it goes against the definition of direct proportionality to have two values which are positive and negative, both giving you a positive value, okay? At this level, as a general rule of thumb, if you're asked to find a value when given a positive value, your answer should be positive, and vice versa, okay? Let's look at the last question of this tutorial. So in this question, we're told that a, b, and c are three variables. A is proportional to b squared. A is also proportional to the square root of c. B equals 4.5 when c is equal to 2.25. And we've been asked to find b when c is equal to 8, giving our answer correct to 3 significant figures. So I'm just going to give you a few seconds to pause the video to have a go at this final question yourself. Otherwise, feel free to skip straight to the solutions. Welcome back. So this is a much trickier question. And what makes this question different from the previous questions is that here there are two different statements of proportionality. A is proportional to b squared, and a is also proportional to the square root of c. Now, in order to find b when c is equal to 8, we need to use these facts to find a general formula that shows the relationship between the variables b and c. Now, there are a few steps in order to getting to this formula, which we'll go through now. So let's start off with the first statement of proportionality, that a is proportional to b squared. So we can write this statement, and therefore we can say that a is equal to k times by b squared, where k is a constant to be found. And let's label this equation 1. Looking at the second statement of proportionality, which says that a is also proportional to the square root of c, we can write the following. And therefore a is equal to m times by the square root of c, where this time we've used the letter m to symbolize the constant of proportionality. And the reason why we've used a different letter is because we can't assume that the constants are the same. So let's label this equation 2. Now, remembering that our plan of action was to find a formula which relates the variables b and c, well, noticing that we have two equations which are equal to a, we can get a step closer to this by setting equation 1 equal to equation 2 to get that kb squared is equal to m times by the square root of c. And let's just call this equation 3. Now, we can see we have a formula of b in terms of c, but the problem is these constant terms k and m in this equation. So we need to find a way of eliminating these constant terms. Now, using the condition that b is equal to 4.5 when c is equal to 2.25, if we sub these values into equation 3, we get the following. We get k times 4.5 squared is equal to m root 2.25. And evaluating terms on both sides of the equation, we get 20.25k is equal to 1.5m. At this stage, how do you think we eliminate the constant terms in equation 3? Well, if we were to set m to be the subject of this equation, by dividing both sides by 1.5, we would get that m is equal to 13.5k. And so now we have m in terms of k. What we can do is substitute this expression for m into equation 3 to get kb squared is equal to 13.5k, the new expression for m, square root c. And now we can see that we can cancel k on both sides of the equation to give us, therefore, b squared is equal to 13.5 root c. So now we have a formula for b in terms of c, which I'll just put a square around. We can use this formula to find b when c is equal to 8 by subbing this value into this formula, giving us that b squared is equal to 13.5 times square root of 8. Evaluating the right hand side, we get that b squared is equal to 38.183 and so on. And taking the square root of both sides, we get that b is equal to positive 6.179 and so on. We're using the positive version of this value because the value that we input into this formula was a positive value, so we should get a positive output, and this is equal to positive 6.18 rounded to 3 significant figures. Okay, so we've gone through several examples of direct proportion using formulas. I hope this was somewhat useful for your revision. Keep up the good work and I'll see you in the next tutorial. If you like this video, please give us a thumbs up, leave your comments down below, and subscribe to this channel so you'll be the first to know when we release our next videos.